Okay, so when we talk about trigonometric integrals, we're talking about integrals with the trig functions in them. And we've already looked at some of those, but we're going to see if we can, kind of categorize them and look for techniques to address different types. Now, one of the things you need to keep in mind, here's some basic ideas. Remember, sine squared x plus cosine squared x equals 1. So you want to remember that. And the other two Pythagorean identities as well. So remember that tangent squared x plus 1 equals secant squared x. And cotangent squared x plus 1 equals cosecant squared x. So these are some integrals that are some three identities that you really need to keep in mind as we're going through here. So if you don't know those, you need to go back and remember them because you're going to be seeing a lot of those. Now there's another identity that you may not be as familiar to you, and that is the power reducing identities. So for example, if you've got sine squared x, that's going to equal 1/2 times 1 minus cosine 2x. Now, it's not always 2x. If you had cosine squared 2x here, then the inside would be 4x. In other words, this right here is always double this, okay? So, if that were 4x, that would be 8x over there. And then you also have cosine squared x is 1/2 1 plus cosine 2x. So, they're very similar. But these are ones you need to remember as well. So we have the Pythagorean identities, and then I'll have what's called, I'll call these the power reducing identities. Now, what I'm going to look at first involves these power reducing identities. So what we're going to look at right away is just what happens if you have an integral like this. Let's suppose we have sine squared x dx. Now, without that power reducing identity, we really don't know how to approach this. But with a power reducing identity, we can do this. We can say, well, this is going to be 1/2 1 minus cosine 2x dx. Now, immediately we have something that we can deal with because we don't have everything's to the first power. And that helps us in our integration. So I'm going to factor out the 1/2. I'll just do this a step at a time. And we get this. Now, I can integrate each part of this, right? So the integral of 1 is just x. The integral of cosine, well, it's going to be sine, right? The antiderivative of cosine is sine. But this is not the antiderivative of cosine x. It's the antiderivative of cosine 2x, which the 2x is just a linear term. So remember, we can write that as sine 2x, and we just remember to divide by the derivative of the inside. Okay? Or you could go through a whole substitution, but you would find, yeah, I'm just dividing by the derivative of the inside. Okay? Now, this is how we approach integration when we've got just sine raised to some power, or the same approach could be taken with cosine raised to some power. Now, sometimes raised to some even power, not just some power, some even power. Now, let's suppose that we have this. Let's suppose that we have sine squared x cosine squared x. And, you're not going to let u be sine or u be cosine because that's not going to really help you. But what you can do is you can replace the sine with this power reducing identity. Okay, so let's do that. And then we get this. We get 1 minus cosine 2x. And I'll replace cosine with the same, its version of it. And let me put this whole thing dx, okay? So we work the integral, we rewrite the integral this way. And we're in a little better shape now. notice that I can take the 1/2 here and the 1/2 here, multiply those, and then just set them on the outside. You're not going to factor out a 1/2. You're actually going to multiply them and then set the 1/4 on the outside. So what we have is 1/4, and then we have 1 minus cosine 2x, 1 plus cosine 2x. And then we just multiply out these little fellas. That's what we do. We multiply them out. And those are just conjugates, right? 1 minus, 1 plus, difference of squares. So that makes the multiplication pretty easy. We got 1 minus cosine squared 2x. Okay? Everybody follow me? What I got? Okay. Now, we're right back where we have a square thing, right? A cosine squared. So we have to use that power reducing formula again. And here we go. So we've got 1/4. Now inside the integral, I'll just leave this 1 as it is for now. But we have minus 1/2, 1 plus cosine. Now be careful, it's not 2x, it's 4x now. Because it's double what's in there. You have to be careful. Okay. Now that we're at that point here, I just want to simplify the integral a little bit on the inside, the integrand. So I've got 1/4, and now, look, I've got 1 minus 1/2. Well, that's 1/2, right? 1 minus 1/2 here. And then minus 1/2 cosine 4x. Does everybody see where I got that? See, I had this 1/2 times 1, yeah, and then I have the 1 here, 1 minus 1/2. Okay. Now I can go through here, and I think at this point I'm ready to go ahead and roll up my sleeves and integrate. So I've got 1/4, and in here I've got 1/2 x minus 1/8 sine 4x plus c. And there you have it. Okay. Does everybody see that, how that works? Okay. Okay, now, that's how we deal when we have sine raised to some even power by itself, cosine raised to some even power by itself, or the two together, each being raised to an even power. That's how we deal with it. Yes, sir? Well, there's a different method for odd powers. And remember, this is the power reducing formula, so it works when we're reducing even powers of sine. Okay? Now, if we're going to work with, if we're going to look at odd powers, so let's look at this. Let's look at odd powers for sine and cosine. Let's suppose I've got sine cubed x dx. Okay? Well, now we're not going to use the power reducing formula, although, you know, we could set this up and call it sine x times sine. I mean, we could call it sine squared x times sine x, and there we have an even power, but that's not going to help us too much if we tried to do that to use the power reducing formula. However, we could split it up. I could split this up and take a different approach. Okay, so look, I've split it up. Now, what I'm not going to do is rewrite the sine squared as 1/2 1 minus cosine 2x. That wouldn't really help us that much, if at all. But I know that I can write sine squared x as 1 minus cosine squared x. Okay? So, dig this. 1 minus cosine squared x. And then sine x. Ah, look at this. Now remember, what we're always trying to do here is we want to, like, we're in a position now where we can substitute. And the idea is we're going to let u be something, and then du takes care of the rest of it. So by changing variables, we're hoping or by making a substitution, we're hoping to get an integral that's a little bit easier for us. Now, we notice that cosine and sine have a relationship here. The derivative of cosine is sine. So let me just do this. Let me just say, well, let u be cosine. Then if I do that, then du is negative sine x dx. Now, notice I didn't let u be the entire thing, 1 minus cosine squared. I didn't let u be cosine squared. I let u be cosine. And now I've got negative du is equal to sine x dx. Well, now we've got something that we can deal with. I'm going to replace the dx, the sine dx, with negative du. And then I've just got 1 minus u squared du. See? And now that integral is pretty tame. It's just got 1 minus u squared. So that is going to give us negative u minus 1/3 u cubed plus constant. There it is. Very easy, right? Okay, nice and easy. Now, so when we have an odd power of cosine, we think about it in those terms. Okay? Now, this was sine cubed. Imagine if we had sine to the 5th. Okay? If we had sine to the 5th, you can see that a similar approach would work. So, and in fact, instead of sine 5th, let me do cosine to the 5th. Cosine 5th. Okay? So let's try this. Now, I'll do this. I'll split it up, and I'll call this cosine squared x, cosine squared x, cosine x. And of course, I could have said cosine squared, but let me just do it that way. Now you can see that I can write it this way. I can say, okay, that's 1 minus sine squared x. 1 minus sine squared x, cosine x. Now, you can see that this is an integral that we can work with, because I could do this. I could say, well, let u be sine x, then du is cosine x dx. And now we have this, 1 minus u squared du. Now we can multiply this out and get an integral that is just a delight, right? So we have 1 minus 2u squared plus u to the 4th du. Yeah, and you can take it from there, right? Okay. Any questions about that? Okay, so we're taking these complicated things and we're getting these little nice polynomial things that we can integrate. Okay? Okay, any questions about that? Okay, so we have gotten to the point where we say, okay, I know how to deal with sine and cosine being raised to even powers. I know how to deal with sine and cosine being raised to odd powers. But now we can put them together. So let's look at this. Let's suppose that we have something where we don't just have sine, we don't just have cosine. We're going to have cosine in here, and we're going to have sine in here. Now, if I stop right there, I mean, all of you can integrate this. You could just let u be sine and then du is cosine and so forth. But here's what I want to do. I want to raise this sine to the 3rd power and this cosine to the 4th power. Let's do something like that. So now we've kind of mixed them up, right? We don't just have sine, we don't just have cosine. Now we have an even power of cosine, an odd power of sine. And I could swap these, right? I could have an odd power of cosine, even power of sine. Same principle is going to work here. Now, here's what we can do. I notice that what I'm looking for is I want to let u be either sine or cosine and then du be the rest of it. That's what I really want in my heart. So let me just go through here and see what I can do. One of the things I notice is I've got cosine to the fourth x, and then I can write this as sine squared x sine x. I can do that. Now, the reason I did that is because I would like to write that sine squared in terms of cosine. So, in other words, what I've got in my mind is this. I know I can write this as 1 minus cosine squared x. And then I've got sine x dx. Now I'm in a position where I can let u be cosine. I can let u be cosine. Okay, so here it goes. Let u be cosine x. Then du is negative sine x. And that would be negative du is equal to sine x dx. Now look how this integral simplifies. I've got u to the negative here, u to the fourth, 1 minus u squared du. Super easy, right? This one we can integrate, no problem. Okay, any questions? Okay, so you can see now, what I don't want to do is try to just start giving you formulas. If this happens, then do this. I want you to be able to look and know, okay, I know generally how to approach these problems. I don't, although your book has, you know, if this power is even, this power is odd, do this and that. But the idea, what I want you to be able to do is look at these and kind of analyze them and see if you can figure it out. Any questions about this? Now, the next thing is involving secant and tangent. Okay, secant and tangent. So let's just look at something here. Let's suppose that we have this situation here. Let's suppose that we have tangent to the fourth secant squared x dx. Let's suppose that we have that problem. Now, already you can do this, right? You know how to solve this because you have a tangent and a secant in here, and one of the things that should jump out at you is secant squared. Hey, that's the derivative of tangent. So right away, you can let u be tangent, then du is secant squared x dx. Look at that. U to the fourth du. And let me go ahead and finish that one off. That one's easy. Okay. So no problem. Does everybody see that? So what you're doing is, just like with sine and cosine, how they're related with their derivatives, tangent and secant have a relationship too. Now, let me look at this one. Let's suppose that we have this. Let's suppose that we have secant squared x tangent. Well, let me do this. Let me. Well, hang on. Let me go back here. Let's do secant to the fifth x, and then let's do secant x tan x. Because okay, so let's look at this one. Now, I wrote this one out. It's kind of awkward there, the way I wrote it. I wrote it secant to the fifth x, secant x. You might say, well, why didn't you just say secant to the sixth? Okay, so what I did was I kind of jumped ahead in a process. This integral probably would have been given to you this way. Secant to the 6x tan x. Okay? But this doesn't help us that much. Now, notice that, do you see anything here that might be helpful? I mean, do you see a relationship here? Yeah, you're looking, say, oh, I've got a secant and a tangent together. I wonder if I let u be tangent, will that help me? Because I didn't need secant squared. No, not in this case. So then you say, well, what about if I let u be secant? Ah, jackpot. You hit the jackpot now. Because du is equal to secant x tan x dx. So it looks like what we have here now is u to the 5th du. Looks a lot like that other problem. So this is how we deal when we have secant and tangent together. Does everybody see that? Any questions? Okay, now I want to get to a place where you can start working, but remember, you might also have something like this. Let's suppose that you have tangent cubed x dx. Just tangent by itself. Now, if it were just tangent, not tangent cubed, you know that you can let that be sine over cosine, let u be cosine, and go from there. But this is tangent cubed. So you're going to need to manipulate it a little bit. And one of the ways we can do that maybe is, let's see here, what if we do tangent x times tangent squared x? Okay. I mean, that's about all we can do, right, as far as switching things up. And we're just working through here. So I'm just thinking out loud. But I notice that tangent x, because what I'm trying to do is pull a secant in here. That's what I'd like to do, is pull a secant in here. And I know that secant is 1 plus, well, tangent is secant squared x minus 1, right? Tangent squared. Isn't that right? Okay? Because tangent squared x plus 1 is secant squared x, so that must be, that must be what I'm looking for right there. Now look, these can get more complicated, but if you have tangent to the 3rd, the same thing, the same process is going to be like tangent to the 5th. It's just going to be more work. But now look what you can do. You can split these. Tangent x, secant squared x. That's one integral. And then minus tangent x. See, you can just split that integral apart. Okay, now this is a straightforward, let u equal tangent, then du is secant squared. So that one's easy, right? Because then what you would get is you would just get u du. Okay, hard to get a simpler integral than that. This one over here is going to be negative natural log cosine. Okay. Because that one's just a straightforward substitution here. You let u be cosine, then du is negative sine, and the negative with this negative makes a plus, and there you have it. And of course, you can finish this off. Okay, any questions about that? Okay, no, any questions? Okay, so I think this is enough to get you started on some of these. You just play around with them using the power reducing and also using the Pythagorean identities. That's what you use on